Okay, so we're starting a brand new unit. It is a continuation of Unit 4, which we first learned about linear equations. We're still talking about lines on a graph. And before we see what our next lesson looks like, I wanted to do a little bit of a review / warm up. So this should be a lot of review for you, so let's fly through it pretty quickly. So whenever you see an equation like this that is not solved for y, solved for y means the only thing on one side of the equal sign has to be the y. And in other words, we want to put it in slope-intercept form. So solve for y means put it in slope-intercept form, which is y equals mx plus b. And we should have a really good feel for what both the m and the b are by now. So if I'm looking at this, I need to answer what's in the way. What is in the way that needs to go from having y by itself? And we have a positive 5 that needs to go. Okay, basically I need it to be over here. Well, how will we get rid of it? So we learned back in Unit 3 from solving equations that anytime I need to get something to the other side of the equation to be canceled out, that I use inverse operations. So I want to subtract 5 from both sides. Now, we learned this already. We have a 3x and a negative 5. Many of you are wanting to combine that, which is what we did in solving equations, but this is linear equations, which means we have variables and constants, and those are not like terms. So if you remember that you can't combine x's with constants, then you have a decision. You have to just rewrite it. I have a 3x minus 5, and that is all that I can do. Now, I mean, you could write it as you could put the negative 5 first, and then you could put the 3x, and it works, but it does not is what we're used to seeing. So make sure you understand that you can choose the slope-intercept form would be the mx with the slope here first, and then the b, which will put a negative 5, okay? So let's do another example. Here I see again that the y is not solved for. It's not in slope-intercept form. I need to get it in slope-intercept form. What needs to go? This time I have a variable and a coefficient that needs to go. The same thing they needed to do. Like if I have a negative 8x that I need to get rid of, then I want to do inverse operations and add 8x to both sides. Some of you used to put that line there, right? So you're seeing that what you do to one side, you have to do to the other side. That's going to bring down your y and leave you with a y equals, and then you have a decision to make. Are you going to put 12 plus 8x, or do you like it to have the x term first and go from there? So our slope-intercept form here is y equals 8x plus 12. This is a review, okay? So this one's going to look a little bit different because I see some parentheses, and if we remember what we learned from equations, we always do this first, and hopefully you remember the name of that property. We are multiplying everything in there by that, so that means that you are being asked to distribute. So we are always going to distribute first, and then after we distributed in equations, we always combined like terms, okay? So let's do that. Let's distribute first. And anything I don't distribute, I just bring right down. 2 times x is 2x, 2 times 1 is 2. And so what needed to go now? Now we're back at this problem here. I'm going to add 5 to both sides. Now, this one looks a little different than the first two, because last time when I moved this 8x over, there was nothing to combine, or when I moved the 5, there was nothing to combine. But I want you to see what happens when I move this over. Notice that I put this constant underneath this one. There are no other x terms to combine, so you're bringing that down, and then you are combining your 2 and your 5, and you're getting 7. So what needed to go first? The 5. How did we get rid of it? We added 5. And after we added 5 and combined it with that 2, we get a slope-intercept equation of y equals 2x plus 7. And now I want you to pause the video and go ahead and try that one yourself. Okay, so you should have had a chance to do this. Hopefully you distributed first. We're kind of, these notes here were there for you to guide you, but now we're not going to always have those to fill in. So I wanted to see if you could remember that. 3x, 3 times negative 4. Then you need to subtract 7 from both sides. You bring down your y. That should be equal to your 3x. And then I have 2 negative numbers to add. 12 negatives plus 7 more negatives gives me 19 negatives. And there's your slope-intercept form. Okay, so this is a review. Let's flip over to the back side and take a look at some trickier ones. Now, the front side of these notes was a review. This side is not. This is new. Okay, so if you look and you see an equation like this, it requires more than just getting rid of one thing like the first examples did. So we're getting a little bit harder here. So if I want to get y by itself, this negative 6x is in the way. I need to take that whole x term and get it over to the other side. So to do that, I want to say I need to cancel out that negative 6x. That's the first thing, okay? And I will do that by adding 6x to both sides. All right, let's do that first. Then we'll figure out what has to go next. So let's take this and add it. And remember, if you need to do that line, that helps. Okay, after that cancels, this is what's left. I have a 2y equals, and again, I can't combine these, so you're just gonna write 6x plus 8. Now what needs to go? Is y by itself yet? No, there is a coefficient of 2 there. And it wasn't being added or subtracted to y, it's being multiplied by y. So if you remember from inverse operations, I'm not going to add or subtract anything. I'm going to divide because I need to get rid of that 2 coefficient, and the opposite of multiplication is division. So I want to divide by 2. So I'm going to do this. Now, this is where the new part comes in. I go to divide it here, and I want to bring you back to like if I had 3y equals 12 in an equation, a really simple equation. You've done this 1,000 times. You've divided by 3, divided the one thing that was over there by 3, and you got a value of 4. Well, when I go to divide this side of the equation by y, there's more than just one term. There's 2. It's an expression. So watch what you're going to do. You're going to divide all 3 of these things by this coefficient. So you're going to draw a line under the 2 to cancel it. That's the reason we did it over here. And I have to put it under here and here. And you guys, all this means is take this 6x and divide it by 2. 2 fits into 6 3 times. Don't forget the x. And 2 fits into 8 times 8 4 times. So it's like a triple division. Okay, and I want to show you what we did. We looked at the original problem and we saw that we needed to move the whole negative 6 and the x. And because it was subtraction, that's why we added. And because there was a coefficient in front of y, that's why we divided. So this is going to be either add or subtract for your first step and then divide for your third. So let's take a look at this one. What needs to go first? What is in the way? Y is in the second spot this time. No big deal. Who cares? I need this 6x to go. So I need to get rid of that 6x, and it's a positive 6x. So the only way to get rid of it this time is to subtract it from both sides. So let's do that. Let's do it here. I'll do one more with this line, and then here, okay? After I cancel it here, that leaves me with a 3y. So we're halfway there. I can decide what order I want to put it in. I like to put my x term first. So now what needs to go? There's a 3 in the way of this y being by itself. So the 3 needs to go, but there's no plus or minus sign in between, which means it's multiplication, and the opposite of multiplication is dividing. So I'm going to divide not just both sides, all 3 things by 3. And that cancels it here. That leaves us with y by itself right here. And then how many times does 3 fit into negative 6x? Twice. And 3 divided by negative 9 is negative 3. Okay, so that is my slope-intercept form. And these are a little more involved than the ones we've done before. So we're going to do 2 more examples together. And then you're going to have the opportunity to try a couple yourself. All right. Now, this one looks a little bit trickier here. I don't have an x term to get rid of. The x term is already over there. It doesn't matter what's there. This is the last thing you're going to do. This negative 24 is in the way. It's literally, you guys, whatever is not immediately with the y. So to do that, I need to add 24 to both sides. So let's do that. Let's do a 24 here and add a 24 here. It cancels here, which allows me to bring down my negative 4y. I'm halfway there. This I can't combine because one has an x and one doesn't, so I'm just gonna do this. And then what needs to go next to get this y by itself? That -4 needs to go. And because it's right up next to it, I need to divide. That whole second step about the next, you guys, it's always going to be divide, because that's how you always get rid of a constant, or a coefficient in front of a variable. So we're going to divide by -4. Watch what I do. I want to divide it here, here, and here. And remember, don't forget, some of you, when we did equations, you were canceling this out with a +4. You need the negative and the 4 to cancel. So let's see what that leaves us with. That leaves me with a negative going into a positive, which is a negative. And then this negative is going into this positive, which is going to give you a negative. Now, if this 24 was negative, I don't know if I did an example like this or not, but if this 24 was negative, that 6 would be positive, you guys, because this negative and this negative would cancel, and that would make it a plus. But let's see if we get to that one. So I got y equals -3x minus 6. Let's do one more before I set you free. Let's take a look at this one. I need the y term to stay. So what's in the way? A -3x, and I want to add that 3x to both sides. So let's do that. That's going to bring down your y term. That's going to give you a big mishmash of stuff over here. Okay? Let's do something for a second for me. Let's change this problem, because I can't believe I didn't put an example like this on here. Make that 4y negative for me. So that means we're going to bring down a -4y. And now look what I'm about to do. I'm about to divide by a -4, -4, -4. And I did this problem for a couple reasons, because a couple things happen. Well, first of all, I have a 3 and a 4. And in all these other examples, the number that I divided by 4 went into 12 evenly. It went into 24. 3 went into 6. 3 went into 9. 2 went into... Well, that doesn't always happen. So as I'm looking at this, and I go to divide this -4 into this 3, it doesn't work that way, because 4 does not go evenly. You guys, when this happens, you just leave it. You're looking at a slope of 3/4, but now there's only one negative, right? So you have to put the negative somewhere. It can stay with the 4 if you want. It doesn't have to. The whole 3/4 is negative. It doesn't matter which one. The important thing is that you could make that to a decimal if you want, but because it's slope, we want to keep it -3/4. Now, I had you change this problem here for a reason, because I wanted you to see what happens when you have a -8 divided by a -4, and that's going to give you a +2. So you guys, when you go to divide, if you see two negatives, you have to make it a positive. So we had to get rid of the -4 next, and we did that by dividing by -4, which left us with a slope-intercept form of -3/4 x. The x can go in the middle. And then +2. So I'm going to give you a minute or so to try these. Pause the video right now and give these two a try. All right, let's take a look at this. We want to keep this -5 here, so I want to get rid of the 15, and I'm going to do that by subtracting it from both sides. -15. -15. It doesn't matter what spot it's in. If it's not the y, it needs to go. I canceled it here. I'm bringing down my -5y. Clean this up a little bit. 10x -15. What needs to go next to get y by itself? A -5 is in my way. It's being multiplied, so I want to divide both sides by the negative also. So let's do that. Let's do it to all 3 terms in this problem. And that's going to leave me with how many? Now, first of all, I have one negative and one positive, so that's going to give me a negative answer. 5 fits into 10 twice, so my slope is -2. And my y-intercept, my beginning value, is going to be 3, because that's how many 5s fit in. So I have a slope-intercept form of -2x plus 3. Last one for this warm-up lesson. And the y is okay where it's at. This is what's in the way, so let's subtract it. Let's bring this down. -3y equals, let's put our 7x first. And I want to show you something here. I'm not sure what you got. You probably weren't sure what to do with this when you did this problem. I'm going to tell you something super, super simple. Everybody sees an improper fraction and thinks like they have to make it a mixed number or they have to make it a decimal. No, this is 8th grade. You can just leave it. 7/3 is 7/3, but don't forget the negative. So just leave it 7/3. And actually, you know you want to leave it 7/3 because slope is defined as rise over run, remember? So if I'm going to eventually be plotting this, I want it to say drop down 7, run to the right 3. Don't make it 2 1/3. Just leave it. And a negative divided by a negative is a positive 2. So what needed to go first? Just from looking at it, I needed to get rid of the 6, and I did that by subtracting 6. What needed to go next? I needed to get rid of that -3 because it was a coefficient. I divided both sides by that -3. You guys, that left me with a slope-intercept form equation of, oops, forgot the x. And that is such a common thing. I'm so happy that actually happened. It's a totally different problem without the x, you guys. You cannot forget that x, okay? The whole point of the problem is to put it in that slope-intercept form, okay?